Good morning, students. Welcome back to science class. Today we will start a new chapter, that is the magnetic effects of electric current. Okay. See, in electricity chapter, we had studied the heating effect of electric current. You know, while moving electrons in a wire or in a conductor, what will happen? They will collide with neighboring atoms. So due to that collision, heat is generated in that conductor. So we call that as heating effect of electric current. Okay. So today we will study one more effect of electric current, that is magnet. Okay. So magnetic effects of electric current. Okay. Before that, you know about magnetism. I think you have played with some magnets. Okay, in magnets you have played this kind of magnets. For example, take this is, we call this as north south. Okay, so we call this a bar magnet and needle magnet, horse magnet. There are different types of magnets are there. Okay, but you have played, right? Here when you bring some what happens when you bring some pieces of iron or nickel, what will happen? It will attract. Or when you bring one more magnet here, one more magnet here. Okay, so even that magnet both are attracts, but only one side it will attract, not other side. Okay, I think you have played you know, while bringing some side, the when you two sides, for example, take these two magnets, both will attract. Suppose if you bring another side, it will repel. Okay, both the magnets they will move away. Okay, so we'll discuss later. Mm. So before that, first we'll study, you know, the magnet properties of magnet. Okay, properties of magnets. Okay, see first one. A magnet attracts materials like iron, cobalt, and nickel. Already you know, right? A magnet attracts a magnet attracts materials like and nickel. So this is the first property of magnets. What? A magnet attracts materials like iron, cobalt, and nickel. Okay. Yes, already know. Already updated with this one. Okay. Next, second property. Second property. Okay. The attraction is maximum at the ends of the magnet. Okay. The attraction is the attraction is maximum. The attraction is maximum the attraction is maximum at the ends of the attraction is maximum at the ends of the magnet. Okay, for example, take, say this is N and S. Okay, so now this is a magnet at the ends of the here, and this here and here, that magnetic force, it has maximum attraction. Why? Because here at the ends more number of magnetic field lines are there. Okay, so we'll discuss later why it is strong and why it is weaker. Okay, later. Next, third one. Uh, when a bar magnet is suspended by an when a Okay, third one. See, third one, when a bar magnet is suspended by an unspun thread, it orients itself in a north-south direction. For example, take one thread. Just imagine this is a bar magnet. So just tie it and suspend freely. What will happen? See, it will stand like north-south direction. Okay. Third one, when a bar magnet is when a bar magnet is suspended by an unspun thread, it orients it orients itself self it orients. See, when a bar magnet is suspended by an unspun thread, itself it orients itself in north south direction. In north south direction. Okay. Here, when a bar magnet is suspended by an unspun thread, it orients itself in north-south direction. For example, if you suspend a bar magnet like this, north-south, okay. If you suspend like this, okay, then it will stand. It will stand like this, north-south direction. Always, if you twist like that, okay, when you release that one, so at that time also it stands like this only, north-south direction. Okay. Why? Because why it stands like, because Earth is also behaves like a magnet, right? Around that Earth, the few lines are there. Okay. This is the North Pole and South Pole. Okay. Earth is also, see, Earth is also behaving like a magnet. When you suspend freely a bar magnet, it will stand like this. That is in the north-south direction. Why? Because Earth is also behaves like a magnet. Okay. Next, fourth one. Fourth one. When two magnets magnets are brought close together, when two magnets are brought close together, already right, what will happen? So brought together, like poles repel each other. Like poles like poles repel and yes, here when two magnets are brought close together, like poles repel and unlike poles attract each other. Unlike poles attract each other. Okay, so here say these two magnets. This is north and this is south. If you have one more bar magnet, see here. If you north south, okay, if you bring the south side, what will happen? Both will repel each other. Both will repel each other. Okay, but when you bring the unlike poles means, for example, say north to south. At that time, what will happen? Both will attract. Both will attract means like this. Okay, both will attract. So that's why this is the fourth property of magnet. What? When two magnets are brought, when two magnets are brought close together, like poles repel and unlike poles attract each other. Okay. So these are the properties of magnetic. These are the properties of magnets. See, first one, magnet attracts materials like iron, cobalt, and nickel. Okay. Then second one, the attraction is maximum at the ends of the magnets. Okay. You know, before that we study magnetic field. Okay. Here north south. Okay, north south. If you know, around this magnet there are magnetic field lines are there. Okay, we call these are magnetic field lines. Okay, see here, for example, if you keep one object, a piece of cobalt or iron, what will happen? It will attract. Why? Because the magnetic field lines are present here. Okay, so the magnetic field up to, for example, see here, the magnetic field lines are here. So we can say that that magnetic field, it has influence up to this point. Okay, suppose if you keep some pieces here, then it won't attract. So then we can say that there are no magnetic field lines, means there is no magnetic field. So magnetic field nothing but it is a magnetic field lines. Okay, see here, if you keep here, what will happen? It will attract. Why? Because now this it has influence up to here. Why? Because the magnetic field lines are present up to this point. Suppose if you keep here, then it won't attract. Okay, and one more thing, for example, see, you will keep a piece of iron here, and you will keep one here. Okay, so now you have seen, right? So now this piece of iron, it will attract quickly and it will attract a little bit slowly. Why? Because here more number of magnetic field lines are there. What? Here more number of magnetic field lines are there, and here less number of magnetic field lines are there. Okay, so when you move away from the magnet, what will happen? Then the strength or that strongness of that magnetic field, so magnets, that is decreases. So that's why here, observe here more number of magnetic field lines are there, right? So that's why at the ends the magnetic field is more, means the strength of the magnetic field is more. So the magnetic field strength, that is weak when you move away from the magnet. Why? Because here less number of magnetic field lines are there, and here more number of magnetic field lines are there. Okay, so that's why that the strength of the magnetic field, strength of the magnet, it depends on the magnetic field lines. Okay, so where the magnetic field lines are more, at that point that the strength of the magnet is more, and where the magnetic field lines are less, at that point the strength of the magnets is less. Okay, so that's why what is the second property? The attraction is maximum at the ends of the magnet. Why? Because here more number of magnetic field lines are there. Clear? Yes, sir. Next, third one, when a bar magnet is suspended by an unspun thread, okay, what will happen? It will stand, it rotates itself in a north-south direction. And they have told, right? Why? Because Earth is also behaves like a magnet. So that's why when you suspend a bar magnet freely, it stands in a north-south direction. Okay. Next, fourth one, when the two magnets are brought close together, like poles repel and unlike poles attract each other. Okay. When you bring, for example, north side, now what will happen? Both will repel each other. When you bring north and south side, at that time both will attract each other. Okay. Yes, sir. These are the properties of the magnets. So next, move to properties of magnetic field lines. Yes, before that, so already right, I have explained what is a magnetic field. Magnetic field means what? For example, say this is a north and south. Okay, the magnetic field lines are up to here. So then we can say that yes, up to this point, the magnetic field is there. We can say that magnetic field is there. Okay, so we can define the space around a bar magnet. Okay, the definition of magnetic field. The space around a bar magnet. Where its influence. The space around a bar magnet where its influence. Where its influence can be experienced. Is called the magnetic field. Okay, I'll write. The space around a bar magnet. Okay, the space around a magnet where, sorry, the space around a magnet. The space around a, not only bar magnet, okay, all types of magnets, needle or horse magnet. The space around a magnet where its influence can be experienced. Its influence can be experienced. Its influence can be experienced is called magnetic field. Is called magnetic field is called magnetic field of that magnet. Okay, already I told, right? For example, say take this is a magnet, north and south. Okay, north and south. So now here the magnet field lines are arranged. Okay, see, just a minute. Yes. See here, now this magnet, it has an influence up to this point. Why? Because at this point also the magnetic field lines are there. Okay, so we can say that. So now if you keep any object here, what will happen? So it can attract. It can attract. See that attraction may be speed or slow. That is different, but it will attract, right? So then we can say that it has influence up to this point. Okay, so this is called magnetic field. Okay, what is magnetic field? The space around the magnet where its influence can be experienced is called the magnetic field of that magnet. Okay. Yes, next move to magnetic properties of magnetic field lines. So you take one bar magnet, okay, no, south, and just place over one glass, okay, just place over glass, huh? then see just like this. So just imagine this is a bar magnet. See, this is a bar magnet. Just imagine this is a what glass sheet. See, just place like this. Place this glass sheet over the bar magnet like this. Okay. So then put some iron fillings. Put some iron fillings. Okay. Then all the iron fillings they will arrange like this. Like this. See, so these are called magnetic field lines. Okay, so here when you put some iron fillings, what will happen? So all the iron fillings they will arrange like this. Okay, so these lines are called magnetic field lines. Okay, you can find these magnetic field lines around the magnet only. Okay, first property. See, first property, magnetic field lines are imaginary line. Magnetic field lines are imaginary. Magnetic field lines are imaginary. Magnetic field lines are imaginary line used to show the magnetic imaginary line used 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 to show the magnetic field used to show the used to show the magnetic field in a given region. In a given region. Okay. See, this is the first property of a magnetic field lines. Okay. Magnetic field lines are imaginary line. Okay. So we can't see those imaginary lines. But when you put some iron fillings over the bar magnet, so then you can see those imaginary lines. Already have seen, right? North, south. See, when you put iron fillings, all the iron fillings they will arrange in this order. Okay. See, actually these lines are imaginary lines. These lines are imaginary lines. So here we use it to show the magnetic field in a given region. Okay. So this is the first property. What is that? Magnetic field lines are imaginary line used to show the magnetic field in a given region. Okay. Yes. Second one. Second one, magnetic field lines are closed and continuous curves. Okay. Magnetic field lines are closed. Field lines are closed and magnetic field lines are closed okay. Magnetic field lines are closed and continuous curves magnetic field lines are closed and continuous curves are directed from say the magnetic field lines are closed and continuous curves. Already we have seen, right? Okay, see here, north south. It is a continuous and closed curve. Continuous and closed curve. Okay, so magnetic field lines are closed and continuous curves are directed from north pole to south pole. Directed from north pole to south pole. North pole to south pole outside the magnet. Okay, outside the magnet. Outside the magnet. Outside the magnet. And from south pole to north pole. And from south pole to from south pole to from south pole to north pole is inside the magnet. Inside the magnet. Okay, so here the second property, magnetic field lines are closed and curved and continuous curves. Magnetic field lines are closed and continuous curves are directed from north pole to south pole outside the magnet and from the south pole to north pole inside the magnet. Okay, so here okay, see here. What magnetic field lines are closed and continuous curves, and the direction of the magnetic field lines. Direction of the magnetic field lines, that is from north pole to south pole. North pole to south pole, that is outside the magnet. Outside the magnet, and south pole to north pole, that is inside the magnet. Okay, so the direction of the magnetic field lines are north pole to south pole, and the direction of the magnetic field lines inside the magnet, that is south pole to north pole. Okay, maybe in your exam they'll ask for 2 marks. Show the magnetic field lines around, or draw the magnetic field lines around a bar magnet. At that you have to do this one, and you have to show the direction also. Okay, if you put a direction in this direction like this, then it is wrong. Clear? So the direction of the magnetic field lines, that is from north pole to south pole, and that is outside the magnet, and the direction of the magnetic field lines inside the magnet, that is south pole to north pole. Okay, so this is the second property of magnetic field lines. Next, see, just one, next third one, just I will explain. Okay, so here the third property of the magnetic field lines, what? Magnetic field lines are closer together in the region where the magnetic field is strong, and are widely separated in the region where the magnetic field is weak. See, this is the third property of the magnetic field lines. What is that? The magnetic field lines are close together in the region where the magnetic field is strong, and are widely separated in the region where the magnetic field is weak. For example, see here. Now here more see here more number of magnetic field lines are there, right? So at this point we can say that magnetic field is very strong. Okay, magnetic field is very strong. Suppose if you move on from, and suppose here at this point, already explained, right? At this point here less number of magnetic field lines are there, so that's why at this point the magnetic field strength is less. Why? Here less number of magnetic fields are there, and here more number of magnetic field lines are there. Okay, so the strength or the strongness of that magnet, it depends on the magnetic field lines. If more number of magnetic, see, you will consider one point. Suppose here I will consider one point here. Okay, so see, I will consider here more number of more number of magnetic field lines are there. Okay, so then I can say that here the magnetic field strength is more. If the less number of magnetic field lines are here, then we can say that at this point the magnetic field strength is less. Okay, see here when you move away from the magnet, at that time the strength of that magnetic field, the strength of the magnetic field is decreases. Why? Because when you move away from the magnet, what will happen? Only you can see less number of magnetic field lines. Okay, so that's why the strength of the magnet that is decreases. Okay, when you closer to the magnet at that time, so you can see. Suppose if you keep an object, you will experience more magnetic field lines. So that's why we can say that the magnetic field is strength of the magnetic field is more. Okay. Next, third one, magnetic field lines do not intersect each other, and this is also very, very important. Okay, they do not intersect. Okay, intersect means there is no intersection like this. If you take one line, there is the magnetic fields, they won't intersect like this. Okay. So what is the next property? Magnetic field lines do not intersect each other. Next, this is because if you place the magnet compass at that point of intersection, it will orient itself only in one direction and not in two directions. Why? Because here, compass works, it can show only one direction in one time, right? See, in a compass, okay, we use that compass for direction purpose. Okay, just imagine, even that compass is made up of needle. Okay, see now it can show only one direction, right? See now this point, it can show only one direction at a time, north or south, whatever it is. Okay, if two lines intersect, what is the meaning? If the two lines intersect means it should show two directions, correct? So this is impossible. It can show only one direction. Okay, so that's why the magnetic field lines do not intersect each other. Okay, all the magnets arranged like this, they won't intersect. Maybe they can close to each other, but they won't intersect like this. Okay, if they intersect, which means, see, that is impossible. Why? Because compass, when you place a compass at that point, it can show only one direction. Clear? See, magnetic field lines do not intersect each other. This is because if you place the magnetic compass at the point of intersection, it will orient itself only in one direction and not in two directions. Suppose if you place a compass here, okay, it can show only one direction, not two directions. So that's why the magnetic field lines, they will never intersect. Okay, next, last one, the tangent at any point on the magnetic field lines gives the direction of the magnetic field at that point. So this is also the direction of the orientation of the needle of the magnet compass if we kept at that point. Okay, see, before that you should know what is a tangent. Okay, just imagine, take a circle, just draw one line. Okay, see here. Now this line xy, it touches the circle at one point. See, not like this. Okay, so here this circle, it should touch that circle in one point. So then we can say that this line xy is a tangent of this circle. Okay, so clearly the tangent means just one line that touching the circle outside the circle at one point. So now we can say that this P and PQ, this PQ line is tangent of that circle. Okay. Now here the tangent at any point on the magnetic field line gives the direction of the magnetic field at that point. Okay. See here. See here. So now if you take just draw a line like this, okay. So at this point, the direction it will show in this direction. Okay. Even this line also it will show direction in this direction like this. Or if you take the point here at this point, then it will show the direction like this. Or if you take here, okay, to show here. So that's why what the tangent at any point on the magnetic field line, the tangent at any point on the magnetic field line gives the direction of the magnetic field at that point only. At this point, the direction of the magnetic field is like this. And suppose if it is here, then it is like this. So it is here, then it is like this. Okay, so these are the properties of magnetic field lines. See, these 5 properties are very, very important. Okay, for your examination point of view. Okay, maybe for 3 marks or 2 marks. Okay, so I will stop here. So I'll continue the class tomorrow. So tomorrow we'll discuss the magnetic effects of electric current.